Okay, so already record. And then so already WhatsApp to you guys the things that we want to do for today. But then so we try to share this one to get the idea what is the question for today exercise. Hold on, eh. Okay. So we try to share screen. And maybe so we try to close my video. Okay. Can you see guys the question?
Yes, sir. We can see the question.
Thank you. I think I will try to close my video then so that there's no longer. All right. So guys, so this the thing we want to solve for today session. Um, so just pick one of the sample of this question. A customer can afford to purchase approximately 10, okay, 10 on 10 number of module, which the type of the shell 150. So meaning to say, this shell 150 is that the data sheet that's share with you during the class. Okay, that orange in color, that one. Okay, and then from this question, it mentioned the maximum effective cell temperature is recorded at that site is 75 degrees C, while the minimum temperature is 20 degrees C. Okay, and then this question as well mentioned that the maximum irradiance is 1000 watt per meter square from the data and information provider for Fronius and Sunny Boy. Fronius means that the inverter, okay, inverter, and Sunny Boy. Okay, so that's a two brand. But this case, I will think so already share to you the Fronius, okay, Fronius inverter. So if you can remember the function of the inverter to convert the electricity from the DC mode to the AC mode, okay, direct current to the alternating current. And then the question, uh, A, select the most appropriate inverter, okay. If there's not any appropriate, what would you recommend? Okay, so that's first question. And then B, what will the number of module in string? So in other word, what is the numbers of series in series? Okay, in series. Series means that let's say we have let's say the customer give to us 10 module, I mean solar module or PV module, and then what number in series? Maybe 10, maybe 5 times 2, or maybe 1 times 10. It depends based on our calculation. And then it same goes to the C, how many parallel. Same goes to the same concern from the B question. What is the number in parallel? So these three questions we will try to answer during the session. But then, so we'll go it very slow and steady. So whichever things you want to ask, you may ask in the chat box, or maybe you can ask verbally. So there should be no problem. Okay. So stop sharing this one and open for the solution. Okay. So stop sharing this one. Okay. First thing first, guys. Of course, we need to check our data sheet uh, of our PV. Okay, so then we see, because in the question it mentioned 150 150 type of 150. So then we try to look. So try to open this one first. Okay. Right. Uh, so from the question, it mentioned 150. So in other words, what we are trying to do is that we need to refer the data sheet that give us the information for the 150. Okay, so based on this data, we can see in this data sheet, it provide to us Ultra 175, Ultra 165, plus 160, and also plus 150. So for these purposes, we only refer to the data sheet that provide the information for the plus 150. Okay, so so meaning to say, let's say this one. Um, so meaning to say, rated power 150, peak power 150, tolerance peak power plus minus 5, maximum peak power 142.5, and others. Okay, and also for the data temperature coefficient, also we will refer to the plus 150. Okay, so the rest we can ignore based on this question. And the rest we can ignore. So we will go for this part. Okay, so we may refer all the things related to the 150. Okay, so this one and also this one. Okay, so the rest we can ignore. Okay, so we just look this data. Okay, based on this one and others. And then after we get the idea of that, then we see the data from the data sheet just now. Then we just to extract in here. Okay, so to make our life easier, so already put all the data in this kind of form. Okay, because easy for Sir to determine or to check. Okay, so just rewrite again all the data from here. Okay, so in this case 42 means that, so let's say, so this one. Okay, so this is the value VOC. Oh, okay. Okay, so okay, so so for example, guys, for example, so this VOC 42.6, so obtain from this data sheet 150 and VOC 42.6. So just rewrite in this Excel so that can check it easily lah. VOC, STC means that voltage open circuit. O refer to the open, C open to the circuit, STC refer to that we learned previously, STC standard testing condition. Okay, so even this part not mention STC, but referring to this one. So meaning to say this VOC refer to the STC. Okay, I mean all this thing, referring to the STC condition. And then so just plug in all the things. VMP STC 33, just check VMP STC. So check VMP STC. VMP STC 33. Okay, correct. Okay. And then so just put inside here this one. And then so also put this data. Okay, this data actually still based on the data sheet. Still based on the data sheet. So if you can see temperature coefficient VMP, this one, this value 0.152 or maybe 0.461, then we can check. Temperature this one. Okay, so VMP 150. So 152 millivolt Celsius. 152 millivolt Celsius. Okay. So this is the thing. Let's just insert all the data and create this table. Actually, this is just the data from the data sheet, but then so just put inside here. So far, any question, guys, in terms of this table at first, this one? Okay, clear?
So far,
Right.
okay, sir.
Okay, thank you, thank you. Okay, we proceed. And then afterward, since we have the inverter, I think via the WhatsApp so already sent to you guys, but I will try to check it again. Okay, BMCG and BMCG. Okay, inverter. So we try to this one inverter. Inverter. Okay, so already WhatsApp to you guys inverter data sheet. But then so just share here so that everybody, those who are not having that data, then can share it together. Hopefully everybody, I mean 72 student is in the WhatsApp group lah. Otherwise they will miss the all the information. Okay, so this is the inverter, guys. Sample of the inverter string and everything. So how to check this one? So this the brand, okay, the brand Fronius and SMA. Okay, so for today class we just focus on for the Fronius. So this is the model. This is the nominal output. Nominal output means that rated power. Okay, rated power. And then this is the maximum output that the inverter able to produce. And then the input voltage window VDC and maximum input voltage direct current. Okay, and then maximum efficiency. Okay, so this is the thing. If you notice, if you can still remember the PV, let's say this PV, okay, and then go to the inverter, right? This one is inverter. Okay, inverter. Okay, sorry for the handwriting. Okay. Do you guys still remember what is the type of electricity being produced by the PV? Is the DC or AC mode?
DC.
Okay, DC. So that's why this is the input voltage for DC. Okay. So meaning to say here lah, kan? So this one. Input DC, voltage input window, AC, maximum input window. So what is the meaning of the window here, guys, for this inverter? Meaning to say, let's say we have this kind of inverter. Okay. Let's say kan, bukanlah macam ni kan, tapi let's say lah, this kind of shape. Window means that 100, let's say we go for 1G15 and we go for the indoor voltage window 150, 400. Okay. So this the window. This the window. Okay, this the window, which is the highest one is the 400. Okay. And then the lowest one is the 150. Okay. So far, okay, guys. All right. And then what we are trying to do, we need to ensure this arrangement or configuration of area from the PV should not exceed 400 and should not less than 150. Okay. Okay. Right. Okay. Okay lah. Okay. So that's the crucial part because let's say we produce, we arrange that our 10 module just now, and then some of it may exceed or lower than 150, then your PV not function because you putting your inverter with the wrong sizing perhaps, or maybe you are wrongly sizing your PV, which is not fit the range of the allowable range of window for your inverter. So that's why it's a very crucial to select your inverter so that your arrangement of PV may suit in this range to be operated for the next following processes. Okay? Okay guys, okay. So tak tahulah. Okay lah.
Okay, sir.
Alright. Okay. Okay. So stop this one. So and then okay. Meaning to say, the first step, we need to choose the right inverter. Okay, so the right inverter. So how to do this? How to do this? Okay, first thing first, so we'll just put the data, inside here. Put the data inside here. Or I think so we try to go this one first, and then we will see how to select based on this one. So how to estimate inverter nominal power? Okay, guys, this one. So since we have the total array power at STC is 150 for our PV based on this question. Okay, and then we have 10 PV, which is based on the question. Okay, based on the question 10, and then we select the share 150. So 10 times 150 is 1500 watt. Okay, so that's the maximum. And later, guys, optimum rating factor for constant PV in between 0.75 to 0.8, meaning to say 1500 is the maximum. But due to the efficiency losses and everything, we assume, and typically we can try to place the 0.75 or 75% up to 80%, which is 0.75 and 0.8. And then, okay, for nominal power for inverter between 1500 times 0.75 is 1125. Okay, and then 1500 to times 0.8 is 1200 watt. And yet, how to choose the inverter? Okay, since the inverter range or the closest with the range 1125 or 1200 is, sorry, 1125, 1125. Okay, so 1125, 1200, closer is the 1300, which is based on this data sheet. The most close is the 1300. So that's why we choose IG15, brand Fronius, model IG15 is our inverter. As simple as that. Okay, so meaning to say, all this calculation after a while, we may refer IG15 for the entire calculation. Okay, so that's the way how we try to determine the inverter. Okay, so solve problem question number 1. Right, so select the most appropriate inverter, and then after we do the calculation, 10 modules times 150 watt, 1500, and then by having the rating of 0.75 up to 0.8, then we can get the 1125 and 1200, and then we just check in the data sheet what is the close for that particular value, and then we found that IG15 from the Fronius, which offer 1300 watt is the best to be selected for the A question. Okay, so far any question, guys, for the A answer?
Sir,
Yes.
yang 0.75 dengan 0.8 tu macam mana kira? Macam mana dapat?
Okay,
Yang
so who's on the line? Who's on the line?
Jerry.
Oh, Jerry. Oh, bukan Jerry Maguire kan?
Bukan.
Alright, joking ya Jerry ya. Alright, so 0.75, 0.8, there's no any calculation. You just take the value based on the derating factor, which is normally they may use under 0.75 or 0.8. If let's say based on your experience, you may found that the rating factor, let's say 0.7, then you may go for 0.7. But for our purpose of class, then we may stick this 0.75 and 0.8. Jadi,
Oh, maksudnya benda ni akan dibagi lah.
yeah, kalau tidak dibagi, you need to assume, but you assume it should be in this range.
Okay.
Kan, sebab of course certain this varies ni depends, sebab some of the connection may be short wire kan, some of the connection may be require a long wire, which is higher losses throughout the installation and everything. So that we just assume that in the range of the 775 until is 0.8 is the derating factor from the 1500 for the PV total area power at STC, so that we can get this 1125 and 1200. Okay, because what this information we will use to enter the inverter window kan, macam tu. It should be not exceed lah kan, betul tak? Sebab exceed lagilah tak muat kan, dia exceed or lower than this, so we need to fall under this range. Okay, okay jadi ya. Okay.
Okay, okay.
Alright, okay, thank you for the question, Jerry. So may proceed. And then after we go for that, since the inverter range is closer to the range of 1125, then okay, so settle lah. So ini at least actually the IG15 kan, IG15. Okay, settle. Dah dapat dah full mark untuk A question. Okay. And then what is the next question? Apa soalan tadi? So okay, B, what will be the number of module in the string? Okay, so this is the next question lah. Okay, so go for the next following step. And then next, since we know, guys, the all this data, all this data is representing the condition of the STC at 25 degrees C. Okay, so we need to do some sort of the calculation to get the new number of this data, all this data. Because what? From the question, it mentioned that your PV at site is 75. Do you get what I'm trying to say? In the data sheet, it gives you the data on the case of 25 degrees C. But your actual maximum cell efficiency temperature at site is 75. So we need to do some of the calculation to gain the new value based on the specification on the 75 degrees C. So what we are trying to do, of course, it has the equation we need to use. So this is the way. Okay, this is the way. This is the equation. Okay. For firstly, so we start with this equation, yellow in color. Okay, Vmax. Okay, Vmax maximum. OC open circuit equal to the VOC voltage open circuit at STC. Okay, minus gamma VOC times T cell effective minimum minus TSTC. Okay, so gamma for VOC. So we try to address it one by one, so that you can know where this thing come from. So we want to determine the Vmax OC. Okay, so the equation is a VOC STC. So show this one. VOC STC. Okay, VOC STC. Okay, VOC sebesar sikit. Kan besar lagi. Okay, kita nampak. Okay, alright, besar lagi lah. Okay, alright. So VOC STC. So this is the thing, 42.6. Okay, and then what else? Okay, minus in bracket gamma VOC. So gamma VOC, gamma. Okay. Gamma VOC, this one. Okay, lagi. Okay, gamma VOC. T cell effective minimum. So T cell effective minimum means that from your question. This while the minimum temperature is 20 degrees C. So that one you should put the value of 20. Okay, minus STC. TSTC is what? Yes? TSTC? Ada kat check ke? Oh, tak ada. Ingatkan ada kat check. What's the TSTC? Ah, no sir. Apa ni? TSTC is the this one? Sorry. Ni TSTC 35. This yellow in color line, do you guys understand? And can someone verify my calculation? Sir get based on that data 41.86. Can someone verify for sir for this value?
Betul doktor.
Okay, so you guys try to calculate, then we will try to check together lah. Kan? Kan? Cantik kan? So that's the way. Can someone Sepun sambil-sambil tu Sepun nak cuba kira juga lah ya. Manually lah, manually. Kan, VOC, STC berapa? But those, okay, for 186, sama Amanda? Amanda Nurazman, sama? Alright. Al-Amin pun dapat, okay. Terbaik. Baru je saya dah ambil pensel dah. Korang dah dapat dah, okay lah. So, betul lah tu. Ada lain yang lain? Mungkin boleh kita make a good discussion then. Why yes, why not? Okay, betul sir, dapat 41.86. Okay, thank you Amin. Amin Amanda Norazman. Okay, alright. So clear, verified. Seterus ni, verified. My student, verified. My student. Okay guys, next, with the same approach, try to get the blue in color answer. And also the green in color answer. Okay, so first line, verified by student. Okay, and then go for the next one lah. The blue in color, Vmax MP. Vmax MP means that we go for the data sheet and we choose the VMP, which is 33. Okay, and then we insert here STC, and then using the gamma VMP, which is from the data sheet as well. Gamma VMP, oh sorry. I'm using this value. Okay, and then insert and T cell effective minimum. So minimum you can go for minimum lah 20 tadi tu, and then minus of TSTC 25, and then we will wait for others answer. What is the final answer? Okay, so still wait your guys answer. Can you guys verify with my answer? Someone can get the answer for sir? Is that correct? 32.24. You guys? Anyone? Anyone can answer the question? Or you guys just believe my answer, then so we proceed. Trust my answer. So better you guys check, so that you know what is the misleading or the mistake you have been performed, or maybe the mistake from my side, so that we can try to make it proper step of solution later. So careful, we using the others type of gamma, which is previously we are using the gamma VOC, but this time around we are using the gamma BMP. Okay, so that's the thing, which is it has been addressed here, gamma or alpha BMP or gamma or alpha VOC, because it will give you a slightly different value. Okay, 152 and 148. Okay. 3224. Okay, 3224. Asafansuri. Alright. 324. Okay, thank you, Sam. Thank you, Asafansuri. Itu kan nama Asaf. Okay, Nias. Okay, ramai verify. Alright, proceed. 32, okay, clear. Verified by student. And then go for the last one. Vmin MP. Is that 40.61? Okay, so dapat dah juga seorang. Sam, okay, dah dapat. Kita minta lagi dua kawan verify. Kalau lagi dua kawan dapat verify 40.6, then next move lah. Next move. Xiao dapat 40.6. Okay, another one. Xiao, alright. Oh, banyak. Okay. Alright, so confirm. Okay, settle. Alright, so we go. Okay, so this idea, guys, just to give the I would say the data that we may refer to do the sizing for the optimum numbers of PV. Okay, so in other words, Vmax OC 41.86, Vmax MP 32.24, and Vmax MP 40.61. Okay, verified by student, clear. And then next, we need to go for this calculation as well, the maximum and minimum allowable voltage. So our voltage means that it refer to our inverter just now. If you still remember this one, so we are selecting the inverter, okay, IG15, and this the range of the operating condition, okay, all this thing, this one, everything. And then what we are trying to do, we try to go this way. We try to go this way. Okay, assuming this inverter, okay, and then the maximum inverter 500 refer to the data sheet, which is maximum is 500. Okay, and then the Vmax window inverter 400 refer to this one 400, and then V win min inverter 150 refer to this one. And then seems like we try to sketch this thing at first, and then we go for the so-called safety factor, I would say, because we don't want our voltage or our power, it just meet the maximum value, which is 500, then we give 500, then we try to go for the safety factor, which is we go for the slightly lower from this 500, so that what we are trying to do, Vmax inverter allow, Vmax, okay, times 0.95, which is so obtained for 75. So can someone verify for this? Okay, okay, so pada ni, okay, so try someone verify this one. Blue in color at first. Okay, but then it's very straightforward lah. 500 times 0.95, we can gain the 475. And then the Vmax window inverter allow, okay, times 0.95, which is we may obtain 380, which is referring to this one. Okay, this one. Okay. Okay. And then the V min window inverter allow, V min inverter times 1.1, meaning to say 10% increase. So from the 150 become 165. Okay. So this one. So in other words, guys, your space of your inverter seems like more smaller compared to the previous one. Previous one in the range of the 150 to 400. So after we go for this kind of allowable safety factor, then we only allow the range of the uh, input for voltage in the range of the 165 to 380. Okay. So far, any question until we determine this window? Okay, Vmax is max window. This the window. I mean, the range of this thing we call it window inverter. So this is the inverter. Can allow means that after we go for the range of safety factor just now, then this one is the allowable voltage that can be entered to the system. Okay. So far so good, guys. Far so good. Okay. Oh, terus keluar dah Arsfaran. Okay. Okay, okay, okay. Alright. Okay, so okay, we proceed. Okay, aku okay, aku dah sampai rumah Okay, okay. Okay. Um, okay, so this one. Okay, next, guys. So we already determined the Vmax, MP, everything, okay? And then we already determine the window of inverter, okay? And then afterward, we go for the estimated total array power and number of module. Okay. Right. So how to calculate this one, guys? So just grab this one. P array. P is power. Okay. Maybe confused ya. Ingatkan pare kan. P array. Okay. P refer to the power. A array. Array, you guys remember array? Array. What is the meaning of the array? The combination of the
Module.
Okay.
Module.
Okay. Combination of the module, meaning to say it should be not one module lah kan? It should be related to our question, combination of the 10 modules. Kan? Tapi kita tak tahu lah that 10 modules so how it will be connected. Either all in series or all in parallel or combination of the series and parallel. We don't know yet. We don't know yet. Okay. Equal to the P or P refer to the power. P refer to power. Power nominal rated. Okay. Nominal rated. Type 0.8 to P nominal rated divide by 0.75. Oh, ni triple divide ni. Okay. Ada apa? Oh, delta ni. Delta kecil. Alright. Okay. So, why is put 0.8, 0.75? Because at first, we put here 0.8, 0.5. Let's say you go for, let's say, 0.8, 0.9, for example. Then you may go as well this one, 0.8, 0.9. Okay. But for this exercise, so just stick with this 0.75 and 0.8. So that's why the rated that we try to gain over here in the strength of the 0.8, 0.75. And then by having this kind of nominal rated, then we can gain the 1733.33 and 1625. Can someone verify this value? Okay, guys. So we try to check the checkbox. Where's the checkbox? Where's the checkbox? Okay. So this 173 P numerator rated refer to your what datasheet? Inverter datasheet. Okay. Inverter datasheet. Nominal output power. Because all this PV array, guys, want to enter the inverter kan? So we need to use the power from the inverter to assure that this PV array allow to insert this one. Okay. So based on our friend, we get the K. Sam dapat 173. What about the others? Okay. Can someone verify this one? Okay. Alright. Good. One more. Okay. One person, another 1% to verify. Sama saja. Apa sama saja. Okay, Afif. Right. Thank you, Afif. And others. Alright. So this the estimated lah kan? Estimated PV STC estimate. So 1733 and 1625. And then after that, that based on the 0.75 and 0.8 punya ni lah, the rating factor. Uh, in bahasa apa ya, the rating factor, nilai susut lah, susut ataupun losses lah kan, losses. Okay. And then after that, by using our PV selected, okay, and then we estimate the number of module. Okay. So this one. Okay. So then just go for the 1733 divide by 150. Why 150? Because our PV module that we are selected for the STC is 150. 150. 150. Okay. Right? And then it should obtain more or less in the range of the 11.6 and 10.8. Okay, so basically that's the answer. But yet, that's not the final answer, guys, because we just get the idea, the range of the numbers of PV, right? But we still not solve what is the arrangement of the PV. Either this 11 representing the whole in series or parallel, or we never know yet. Okay, so that's the thing. The business start here. Okay, the main business is start here to determine the maximum and minimum number of module per string, which is referring to the question B and C. Okay, B and C. But for now, we go for the B. And then by using this value, n max, n means that the quantity lah, quantity maximum based on the VOC max, okay, equal to the Vmax inverter allow divided by the Vmax open circuit. So Vmax inverter allow, actually we already obtained previously. That's why we go for the calculation. Vmax inverter allow, Vmax inverter allow, Vmax inverter allow. Let's say Vmax inverter allow. Ni 475. Vmax inverter allow. We already calculated, right? This one. Apa ni? Okay, 475. Divide by the Vmax OC. Vmax OC refer to the Vmax OC, not STC, Vmax OC that we calculate based on the operating condition. I mean the temperature. Vmax OC, Vmax OC. Vmax OC, this one. Vmax OC. Okay. And then 475 divide by the 41, 1.86. Then you can get how many? 11.35. Do you get the same answer, guys, for this one? Sorry. Okay, so we try to check your your chat box. If either can get the same answer with sir, then we can try to verify as well the final answer. Ni sama sir ni yang mana ni, Fif? Yang sebelum ni alright. Okay, can someone check for sir? Is that you also gain the same answers 11.35 for the number maximum based on the BOC max? So this part, actually we already calculated previously, and also this part. So just is the matter of inserting the value lah, to get the rough answer. Okay? 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 Someone can verify this answer, 11.35. Hello guys? 11.35. Thank you. Okay, thank you, Sam. 11.75 428. Okay. Anyone verification? Chow was okay. Alright, Chow pun dah tolong sir untuk verify 11.35. Okay. Thank you. Okay. And then we assuming the same answer means that the correct answer lah. Kan? And then what we need to do, since the number of the PV is 11.35, so since there's no any 0.35 module, so that's why we round down. So 11.35 we go round down become as 11. 11.79 we also round down become 11. So actually the maximum number of PV in a string, okay, yeah, in a string means that in the series, maximum is 11. Okay, maximum is 11. Okay, bear in your mind this one. So this one is verified. Okay. And then to determine what is the minimum number of your string, okay, we just go this one, v min window emitter allow, okay, divide by the v min mp 0.95. Okay, so that we can get 4 to 8, okay, which is we round up become 5.0. Okay, so this one. So in other words, guys, to analyze your configuration of array, it should be start from PV 5 unit up to the 11 unit. Okay, so this is the thing. So far so good, guys. Okay, so far so good. Good but not good. Okay, or not good, but proceed faster. Okay. Right. Okay. Just now, guys, we just determine number maximum and minimum in string. Okay, in series lah, I would say. So what about the parallel? So how to determine the parallel? Okay, so what is okay? Hold on. Okay, what is the parallel? I see string at stc. Okay, so need to go for the datasheet stc 5.1. Where is it? Okay, this one short circuit current stc 1.5.1. Okay, and then I max DC inverter. So we need to do with the inverter. So we'll show it afterward. And then the n parallel max, okay, n parallel max is 175. Okay, so this one, so we try to show this one first, how we get the 9 to 1. So 9 to 1, yeah. Okay, so this one, effective of inverter, efficiency of the inverter, from the data sheet, we gain 94.0, okay, 94.0 or 94, okay. P out is the nominal 1300, which is from this one, okay, this one. And then the IDC max, the thing we want to get times V mean window inverter. V mean window inverter is this one, okay. And then we obtain roughly the ID max inverter is 9.22 ampere. So that we include 9.211, I mean 122 lah. Okay, so try to tutup. And then afterward, we just go for the round down. Okay, 9.22 divide by the string. Okay, divide by the 5.1. Okay, with the safety factor of the 1.25, and then we get 1.45, and we can round down become the 1. Okay, 1. Okay, so this one, okay guys, can someone verify the answer for sir? The 145, this one. 145. Okay, thank you, Chia. Right. Others? Dapatan ya, Chia. Dapatan ke dapat? Dapatkan ke? Dapatan. Right, 1445. Okay, thank you, Chia. And then we know the parallel is 1. Okay, and the maximum string that we can obtain for this arrangement for that particular inverter is from 5 to 11, right? So what is the meaning of this data? Means that by having this table, the maximum series is maximum is 11 based on our calculation here. Based on the calculation here, this one, okay. Maximum 11. Okay. So this is the maximum 11. Okay. And then n parallel, number of parallel is 1. Why 1? Because here, let's say number parallel max is 5. Then you start with 5 here. And of course, this one as well. Let's say the n series 10, for example. Then you may put this one is 10. Okay. And then how to develop the rest this one? This is the maximum 11. And then how about this one 5. So your table should be go for the minimum 5, because this one so already simplify this one. So it should be start from 5, 6, 7, 8, 9, 10, 11. Because this one 5 refer to this case. 5. Minimum. Maximum is 11. So that's why 11 here. 5, 11. Minimum, maximum. And then it should be same. Okay. Okay. So far, to tabulate this table, you guys understand, guys? Okay, so far so good. Okay, and then guys, after that, let's say we obtain this n series from the calculation and parallel from the calculation. So we try to hide this one first, to make your life easier to look at. So try to hide this one just to give you, okay. And then n module refer to the n series time n parallel, which is 11 times 1 equal to 11. Let's say your parallel is 2, so your answer is 22 lah for your number. So since the n parallel is 1, so we go for 1. Okay, right. So, and then based on this 11, we need to determine the detail of the percentage, the rating percentage. Okay, so P nominal divided by the P module, which is P nominal is 1,300, and then the P module, PN module, 11, okay, times 150, okay, and then divide by 1650, okay, and then get this one. Can someone verify to sir this 78.8? So this one from the table, from the calculation. This one from the calculation. This one is the n series time n parallel. Then we get the 11. So we skip this one first. So we'll mention it afterward. And then how to obtain this one, 78.8. Can someone share to sir? Are you getting the same answer with sir? P nominal inverter is 1,300 from here. Sorry. So this P nominal kan, P nominal this one, inverter, you gain from this one. You try to take it back from this one, 1300. Okay. And then the P in PN module is the 11 times 150, because your module, one of your module is 150. So times 11, times 11. Times 11, then you can get the, if I'm not mistaken, 1650, and then that 1300 divided by 1650, then you get the more or less similar answer with sir. Can someone verify for sir?
Yes, sir.
Same.
Yes, Sam.
Alright. Okay, good. Thank you. Who's on the line?
Kwa.
Oh, Kuah. Okay, tak keluar lah Kuah, nama Kuah. Okay. 78.78. Okay. Belanja sikit lah. Ni, 78.78. Okay, ke memang 78 je? Saya buka kan susah sikit. Boleh tak? Boleh, sama. Okay. Okay, Ahmad Anis. Okay, Bukhari. Okay. Right. Okay, thank you. And then, guys, that's the only case of the 11 and 1. But if you still remember, we have another option, kan? Based on the data that we are doing, that we have obtained previously, then we need to calculate everything, everything. Kan? Yeah. So guys, try to calculate the others. Okay, try to calculate the others, then we will see how. Okay. Let's say for this part, guys, for that part. Okay, can someone verify to sir? Is that 86.7? Oh, okay, thank you, Sam. Tak sempat sebab nak. Okay. Okay, baru tanya dah dapat Bagus, bagus. Alright, thank you. Alright. Okay, good. Okay. 78, 78, 78, 70. Okay. 86, 86, 86. Okay. Last confirmation. Can you someone verify this line as well? Oh, sorry. Is that 96.3? If yes, then I think you already get the idea how to calculate the rest. Okay. Okay, let's say we already complete to do this calculation, and yet how to determine the appropriate arrangement of PV. Okay. So based on your understanding, what and why we should take the answer. Okay. So number one, 11 times 1. Okay. But put no and 78.8. So are you agree? So say no for this question. I mean, we not accept this one. Do you agree this one? So my answer for these 11 modules is not cannot be accepted even it give the almost 80% status. Okay. And then see go for the 10 times 1, 10, and then 86.7, and then 9 times 1. Okay. So finally, based on this data, so we'll choose this gray in color. Okay. So choose this one. Yes. Yes. Because it nearby for the 80%. Select 1 by 10 array, meaning to say, guys, the array, the parallel only 1, and then the series is 10. Okay, which is close the close for the 80%. 10. So, do you guys agree with my answer, guys? Or you want to ask anything before we end the session? Suka kan? End the session kan? So, I think today we just focus on the calculation. Okay. 96 to 96. Okay, so that one is I think yang 9 modul kan, Faiz kan? Okay. So yes, since we conclude this selected 1 times 10 array which close to 80%, so let's answer the question number question B and C, which is we know the number of string in the range of the 5 to 11, and then many parallel is 1. Okay. And then for the optimum configuration of array is 1 times 10. 1 by 10, 1 by 10 array. Okay. 1 by 10 means that, let's say we have module. So we try to jot down here. Let's say we have a module 1 times 10 tadi kan. Okay. So kita ada 10 lah. 10, 10, 1, 2, 3, sampailah 10. 10. Dia ada satu je. Maksudnya ini positif. Okay. Ini elak ini. Negatif, ini positif, ini negatif, and then masuk dekat inverter. Kan inverter positif, inverter negatif. Ini ada lagi lah. Tapi kita belajar hari ini nak tentukan what is the appropriate inverter to suit with this kind of number of PV. Kan? Okay. Any question, guys?
I have question.
Sure. Amanda?
Why we don't use other number of module macam 5 tu kan? Lebih 100%.
Okay. So yang ni yang 173 kan?
Uh-uh.
Alright. Okay. Thank you. Amanda ya?
Betul.
Okay. Amanda yang mana satu Nanti kita selfie. Selfie lah. Kita tunjuk muka lah. Tak ingat. Amanda. Alright. Thank you for the question, Amanda. Why we choose the... Okay, I think we go just to the basic. Why we go for the 80%? Okay, 80%. Okay. First thing first, when we see the P nominal inverter over the P module, okay. So P module ni is the P module yang 150 kan, 150 which mean yang STC punya condition, P module, because we take the 150 times number of module, then we get the 1000, P module 150 times number of module, let's say 10, so 1500. Okay, and then P nominal is the P from the inverter, which is we must low or low from the from the power. For example, when we have the we consider the another 20% is the losses through the system lah, kan? Losses from the system. So if you can see the nominal that we can claim 80%, it seems like here, Amanda. So we try to this one. This one. Sebab we already claim the power that enter to the inverter in the range of the 80%. So that's why we need to assure the come power inside the inverter also in the range of the 80%. So that's why we need to do some sort of the calculation to assure more or less similar almost with the 80%, which is the best is the 86.7. Because if we go for the exceed the 100%, for example this one, kan 108, 133, 40, seems like they are over the limit of the capacity to the inverter receive the power from the PV. Okay.
Faham sir.
Alright, thank you. Okay. Okay, nak ke mana-mana ni? Alright. How to know the answer is yes or no? Okay. Okay. That's why I partially answer the question. So why we do not say 78 or it more near to 80? Okay. 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 I think I leave this question to you guys to answer, or any opinion from you guys. I think that is a very good question from our friend Kwa. Sir, just repeat. Sir, why we didn't choose 78.8? It's more nearly to 80. Okay. Anyone can try to answer this question?
Sebab dia mampu beli 10 je sir. Betul tak?
Who's on the line?
Afif.
Afif. Okay. Thank you. I think you just get the right answer. Faiz. Afif tadi.
Afif.
The answer is like this, Kwa. Because why sir don't choose this 78.8 even it close to the 80% by having the 11 number of module? Because sir back again the information from the question. Because we just entitled to have only what numbers of module?
10.
10. So kalau kita hanya ada 10 aja, macam mana kita nak pasang 11, kan? So the most appropriate arrangement, which is the most close, is the 10 lah, kan? Sebab yang ni dah tak boleh buat pun sebab 11 kan, sebab in the question we just provide 11 module, 10 module instead of 11. Right? Okay, happy Kau, happy. Okay. Alright, okay. Anyone, anything? Any question, guys? Any question? Before we end the session to celebrate the long holiday. Saya suka holiday ni sebenarnya. Tapi terpaksa buat kelas kan, ganti kan. Okay guys, okay. Um, so we try to look at the chat box first. Okay. So can someone try to recap at least what we have learned today? Ini the best moment ni kan, the best moment ni. Okay, what you learn, I mean new learning lah for you kan, for today's session. Sajalah kan, saja. Cancel randomly pick maybe Daniel Iskandar. Are you around, Daniel Iskandar? Before we end session ni. Thank you, welcome. Not around? Okay, doesn't matter. So we go for other student. Fina Sofia. Fina Sofia, are you around? Okay, not around. So we go for other friend. Izzat Zafran. Izzat? What is that? Okay, tak ada juga. So we go for other student. Nur Syuhada binti Basari. Are you around? Not around. So we go for Shabil Izuddin. Not around. We go for Yi Jiwei. Ada? Yi Jiwei. Ada? Tak ada juga. Not around. Kita try go for Haris. Haris? Ada Haris. 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 Tak ada. Not around. Chow? Ada? Chow?
Yes, sir.
Okay. Chow on the line ya.
Yeah, ciao.
Alright, okay. Chow, can you just give a brief statement, maybe in 30 seconds, what you have learned today? I think the new tips that you are discover by having this kind of session, just to share with the others.
So today we learned that based on the number of solar modules, we choose the most appropriate inverter, and then we arrange it in series and parallel. Then after that, we choose which one is the most appropriate configuration.
Yeah, correct. Because what you guys need to understand, we are not still yet complete the whole sizing, because we just stop at inverter, right? Because we have the configuration of inverter. Let's say we have the inverter. Fortunately, we are given the inverter. But then normally, you will give the very blank of spec. You just given, okay, I want to design this thing for, let's say, 5 kilowatt hour system. So it will go for the different approach to size, because this exercise is very guided, which is already did mention what is the number of module that we can play around with the type of investor as well. But then for the normal or real case situation, normally the customer will ask to us, okay, can you design for me for my house for 5 kilowatt hour? So then you propose to me what is the configuration and what is the cost, like that. Okay, so meaning to say, there's many ways to do the calculation for the sizing. This is one of the approach, which is we are given the inverter. we are given the number of module that we try to calculate. Okay, because we can also have the kind of, let's say, based on our space, roofing size space. Let's say we have the space of the roofing, which is, let's say, 10 meter, okay, 5 meter times 5 meter, for example. So how to do the sizing which fit for the 5 meter times 5 meter, and what the power we will gain by having that kind of area of space. Right? Right?
Yeah.
Kan? Okay, thank you, Chap. So we ask for maybe another one friends, perhaps, before we end the session. So we are close for the 11:30. So I think we can have another one student lah, insyaAllah. Maybe we can go for Safwan. Oh, nama sedap ni, Muhammad Safwan Zainal. Are you around, Safwan?
Hello, yes ada.
Safwan, ada Safwan eh?
Ada.
Ada, tak ada?
Ada.
Hello, Safwan.
Yes ada.
Okay, alright.
Hello.
With the same question lah. So what the new things that you have learned today? Just wrap up for today's session.
Things that I have today.
Kuat sikit Safwan, tak? Your suara macam
Sizing.
jauh, macam tak dengar.
Hello.
Hello, better, okay.
Jadi apa yang belajar ini adalah cara untuk sizing solar module based on customer need, and then refer to the STC.
Okay, correct.
To make appropriate connection, series of parallel, and the number of the module.
Okay, alright. Okay, that's all?
That's all.
Okay, thank you very much, Safwan, for your contribution and for your commitment lah. Okay, thank you very much. Okay, guys, so we towards the end. Also, thank you for the participation. So we'll record this version and later, so we'll share the link for the recorded version. So I pass back one question for you guys to wonder. Okay, maybe you can try to check or discover throughout your free time during your available time, and later try to remind her during the next following 2 weeks. So since in the data sheet, if you notice, we have also the data in term of the NOCT. Kan? We have this one is STC, guys. STC kan? This one. So, and this one is the NOCT. NOCT, nominal operating cell temperature. So, when to use this value, and how do we play around with this kind of figure? Because if you notice, we don't ever touch this NOCT for our calculation, right? We just go for the STC data. So my question, answer question to you guys. So when we will look after this NOCT data? Okay, so surpass that wonder question to you guys during this long holiday to be discovered, and later maybe you can try to share to Sir in a WhatsApp group or in the next following class. Okay, guys? So with that, thank you very much. So thanks for your time, guys. So have a good long weekend. Take care and stay safe. Assalamualaikum warahmatullahi wabarakatuh. Bye-bye.
Salam sir. Thank you.
Thank you, sir.
Malam ni tak ada kelas Malam ni tidur.
Yes, sir.
Malam ni makan Morocco Malam ni tidur. Tak ada kelas
Thank you, sir.
Thank you, sir.
Okay, welcome.
Yes, sir.
Thank you, sir. Okay, welcome.